Hello and welcome to the third video in the D1 chapter Algorithms. If you've got a moment, have a go at the question on the screen. What is the maximum and minimum number of passes needed for a bubble sort on a list with n items? Now we did touch on this in the previous video. Let's have a quick look. We've got 1, 2, 3, up to n. Now we've got two options here in order to maximize or minimize the number of passes needed. To maximize the number of passes, everything is in exactly the opposite order to what we want. So if this is the list going from 1 to n, up in ascending order, and we want descending order, then every pass is going to move the smallest number, which is currently on the left, all the way to the right. And then the next number, which the 2 will then be on the furthest left, will have to move all the way to the furthest right except for the 1. And you'll have to do this n minus 1 times. I say n minus 1 times because when you move the penultimate number, n will already be in its correct place. However, for the bubble sort, you need to finish with a pass that has no swaps. So we add 1 to that, and that takes us back to n number of passes needed. For the minimum number of passes needed, this is a situation where the list is already in the order wanted. So if we want to sort this into ascending order, we need just one pass, and we do need that pass. And in that pass you would find that there were no swaps. No swaps would mean that the sort was finished. So you would have just one. That's the minimum number of passes needed. In this video, we're going to look at the quick sort. The quick sort is obviously another algorithm sorting a list into order. It uses pivots, and it is often quicker, as the name suggests, than a bubble sort, because the number of pivots that you use can increase from pass to pass. Now, it might not increase as many as you would like, but most of the time you will use more than one pivot at some point during the algorithm. You must make it clear which numbers are being used as pivots. That is always said in an exam. What I would suggest is that you put a circle around the pivots and you also list them on the side, because that's how I tend to see it written in the exam mark scheme. The algorithm continues until all the items have been pivots. Now that might seem like it's not going to be very quick if all items have to be pivots, but because you might have more than one pivot per pass, it's not as bad as it might seem. So the algorithm itself looks like this. You highlight the middle item to be the first pivot. If it's an even number of items, then you round up. Then keeping their order. This comes back to that idea of think like a computer. You would instinctively want to change the order as you write down the pivots, because that'll make the whole thing a lot quicker, but you must keep the order given left to right of the other numbers. And we're going to write them either as a list on the left or on the right of the pivot, depending on whether they are smaller or bigger than that pivot number. Once you've done that, that's the first pass complete, and then the pivot number is in its final position. Put a box around that or put a line under that to indicate that, and it should not move from that position for the rest of the sort. Then you've got two lists, one on the left and one on the right of that pivot, and you use these as sublists, and then you just repeat the algorithm on those sublists. You choose the middle terms of the two lists to be new pivots, and you just keep going. You continue making passes until all the items have been pivots, and then at the end you should state that the list is in order. Again, you need to remember this algorithm. It won't be in the exam. So here's an example. Here we have 9 numbers, so the middle is actually a middle. So I'm going to underline my pivots and write on the side what the pivots are. In this pass, it's 28. So what I'm doing is I'm going from left to right. This is important that you keep this order, and I'm going to compare each number with the 28. I'm trying to arrange this into ascending order. So if the numbers are smaller than 28, I'll write them down. If they're bigger than 28, I'll wait until I've written 28 down, then I'll write them down, but still in that order. So 35 is bigger, I'll come back to that. 23 is smaller. 45 is bigger, 22 is smaller. This is where you might be tempted to write the 22 in front of the 23. Don't do that. 23 is first in the list. It needs to stay first before the 22. Miss the 28 because we need to do the whole list first. 39 is bigger, 33 is bigger, 20 is smaller, 41 is bigger. Now I've done all of the smaller numbers, so now 28, and that is where it needs to be. So let me change my notation to match what I usually do. I put a circle around the pivots, and I underline them once they are in their place. Now I go back to the list and I'm going to write all the ones bigger than 28, in order still. Left to right, it's 35, 45, 39, 33, 41. That's the first pass complete. 28 is in the correct place. It should not move from that position. It's the fourth number. It will be the fourth number all the way down to the end. So we're no longer really considering this in our algorithm. So we've got a list on this side. Midpoint of that is 22. That's our new pivot. But we also have a list on the other side. Midpoint there is 39. So we've got two. We're going to do it at the same time on this pass. So 22 on this side of 28. 23 is bigger, so I'm not going to write it down. 20 is smaller. That goes there. Then I'm finished because I've hit 28, which doesn't move. So 22 goes into its right place. 23 is bigger than 22. So I've applied the algorithm on those three numbers as a separate list. 28 is still there. Now the list on the right hand side, these five numbers, I'm looking at 39. 35 is smaller than 39. 45 is not. 33 is. 41 is not. So 39 goes here, and that is fixed in place. 45 is bigger than 39, and so is 41. Now there's a little bit of flexibility here in terms of what the exam expects, but what I would suggest is that you just keep going and treat each of these as pivots. This one, separated by the ones that are in place. Now we've got two lists here of two numbers. So out of these two, the midpoint obviously would be here, but when I say round up, what I mean is take the right-hand number. That is important. If you take the left-hand number, you'll lose marks in the exam. Part of the algorithm is if you've got two numbers, you take the one on the right. So this is my pivot, and so is this. So over here, I've got 20, 23, 33, 41. Obviously, these just stay where they are. Single number lists. 33, I'm comparing 35. 35 is bigger, so I write 33 here. 35 has not yet been a pivot. 39 is here. 41, and then 45. Now 35 and 45. And then I get to write the whole thing out again. 35 obviously is in its right place. And 45 here. All have been pivots. Therefore, the sort is complete. I've done a little bit more than some of the mark schemes require here, but this will get you through the most picky of mark schemes. You've shown all of your pivots here. You've shown them here as well. You've underlined when they get fixed in place, and you've got a full sorted list where they've all been pivots, and also a sort complete statement. Second example. Use the quicksort algorithm to arrange this list into descending order. As with the bubble sort, read the question carefully. And in this case, we've got 10 numbers. So the midpoint would be here, position 5.5, but we round that up to position 6. So here we've got 42. Again, pivots on the side. Make it really clear for your examiner. And then we want numbers bigger than this on the left. 36, no. 19, no. 16, 25, 45 is the first one. 25, 28, 49, 17. So all of the bigger ones are now on the left, so 42 goes here, and that is fixed in place. Now keeping the order given, all the rest, 36, 19, 16, 25, 25, 28, and 17. Now we do the same as before. We've got two separate lists. Middle right is 49 here. And on this side we do have a middle, 25. We've got 49 and 25. Bigger than 49, no, so 49 goes here. Smaller than 49 is 45. 42 is fixed. Bigger than 25, 36, yes. 19, 16, no. 25, yes. I'm going to make that bigger than my pivot. Now you've got a choice here. If it's the same number, you can make it either bigger or smaller than your pivot, but you must be consistent. If you have more than one pair of numbers that's the same, make them all bigger than their pivots, or all smaller than their pivots. Don't mix and match what your decision is on that point. So then I've got 28, also bigger than 25, 17 is not. So this 25 fixed in place, smaller than 25 from left to right is 19, 16, 17. Same again, this list has a middle, this list has a middle. 45, 25 and 16. This one's nice and easy. 45, 42. Bigger than 25 is 36 and 28. So this 25 obviously comes next to this one. Bigger than 16, 19 and 17. Then I've got 28 and 17 middle right. 49, 45, 42. They are all fixed. And then we've got 36, which is going to be the next pivot. 28, 25, 25, 19, the next pivot, 17 and 16. Didn't have to change anything there because the list was already in order. 42, 36, 28, 25, 25, 19, 17, 16. The pivots there were 36 and 19. All have been pivots. Therefore, the sort is complete. There we go. You can see it's the same thing every time. So we're going to move on to an exam question and then we'll finish. Keeping in mind those key points, you must do middle right whenever there are two numbers in the middle. Second, you must make your pivots clear. And third, make sure you keep the order as you write them down on each side of the pivot. All of this is referring to a previous part of the question. Use a quick sort on this list to obtain the fully sorted list. You must make your pivots clear. 2.6, 2.1, 1.7, 2.3, 1.2, 1.8, 2.7, 0.9, 0.8, 0.3 pivots. We've got 10 numbers, so number 6 is our first pivot, middle right. The question that you can't see wanted this in descending order. I can tell that because the bubble sort has happened 3 times, which means these 3 must be in their correct places. So it's descending order. So we've got 2.6, 2.1, 1.7 is smaller, 2.3, 1.2 is smaller, 2.7, and then 1.8 goes here. Then we've got 1.7, 1.2, 0.9, 0.8, and 0.3. Middle of the list and middle right, so that's 2.3 and 0.9, 2.6 and 2.7, so 2.3 is in the right place, 2.1 here, 1.8, and then 0.9, we've got 1.7, that's right, 1.2, 0.9, 0.8, 0.3. And here you can see why it can get quite quick, because now I've got 4 pivots. This one, this one, this one, and this one. 2.7, 2.1, 1.2, and 0.3. So 2.7, 2.6, 2.3, 2.1, 1.8, 1.7, yes is bigger, 1.2, 0.9, 0.8, 0.3, so 2.6, 1.7 and 0.8 are now our pivots, and everything is in order. Some people like to put boxes around the ones that are finished. I used to do that until I realized that a single line, of course, is much quicker than 4 lines. All have been pivots. Therefore, the sort is complete. 3 marks. That should be enough for you to have a go at questions in exercise 1D, and maybe I'll see you for the bin packing algorithms in the next video.